All right, I think we're going to get started. Thank you, everybody, for joining today. My name is ALOK, and I'm one of the founders in STRIIM. And today, I have a fairly broad and macro-level topic. So I'll have to do justice to sort of bringing these pieces together. So the way I'm going to orient the session is we're going to first deconstruct each one of these topics, kind of, at a top level, and then drill down into sort of the core pieces, and then I'm going to bring it back up and connect it together with what all of us are interested in, which is how the heck do we actually make these LLMs work, and particularly with stuff that's practical and stuff that's real world and stuff that you could actually use. Okay, so that's what I'm going to cover today. I tend to speak ahead of my slides. Don't be alarmed if I forward a couple of slides because I tend to use them more as references. I already know what I'm going to talk about, and the intent is not to have you guys focus on every single thing in the slide, but really hopefully just understand the concept and the key takeaways, and I'm going to summarize those at the end. There's also a demo at the end, and if I don't finish or there's some questions, our booth is right here, so I'll be around. So I'm going to talk today a little bit about the data mesh, talk about some of the challenges and consistency requirements. Last year, I laid the foundation of what a mesh is. So this talk actually builds on that. I'm going to talk about some common streaming patterns, and then what does it take to actually fuse, something called Genai into these data meshes, into the pipelines. And then we're going to talk about the actual components of the application and then end with a demo. Okay? So let's get started. Now, this is sort of what the motivation is here, that we want to build a real-world application. This is something that I just found by browsing on the web. It's an example of something where we want to augment a CRM application. When a new company registers, in your CRM systems, you want to trigger a workflow, and you want to use Genai to trigger that workflow. So this is a very common requirement, and the idea here is that this is from Zapier, and they're saying, hey, use prompt engineering for workflow activation so that your messages and your outreach can be more personalized. Okay, so we know the motivation, and the rationale is actually pretty clear. You want to actually know your customers, you want to understand them intimately, you want to use all the knowledge, and you want to also gain operational efficiencies through automation. In reality, just let's take a look at what's going on at a very macro level. When we take a look at customers and enterprises and businesses, they're interested in growth, they're interested in innovation, they want to cut their cost. What they've inherited, though, is sort of a plethora of different systems, and they're very specialized engines. And these engines are sort of what the components are, the end components of what I call a data mesh. And you inherit a lot of complexity with an architecture like this. So right from what engines to use, what workloads are they optimized for? How do you move data across them? How do you keep them consistent? How do you evolve them? There's a lot of research at MIT going on in this area about self-tuning data meshes and trying to sort of adjust workloads, trying to sort of have a uniform query layer so that you can actually try and route the right workload to the right endpoint in the mesh. I forgot to mention that my background, I do come from the Oracle kernel many years ago, so I have a database background. So I'm trying to weave together these concepts of kind of these specialized engines along with data streaming, along with Genai together today. So the one thing that is very clear is that one size does not fit all, and for those of you who actually are practitioners know this very well. And there's literally, today in the real world, there's dozens to hundreds of cloud databases. There's in-memory data grids. There are document DBs that you use to serve up content. There are multiple systems for your Spark jobs, for your machine learning, for your data science. So this is the reality. And when we take a look at just why that is the reality, one of the things, and I talked about this last year, is when we talk about a data mesh, so why do you want a data mesh? One of the core principles of a data mesh is that you want to be able to stand up a data product very quickly, very rapidly, without going through too much hassle, through IT teams and this and that, right? So it's clear that you want the flexibility to stand up your own application without worrying about IT, without worrying about systems. Number two, you want to make sure that your legacy investment is protected and you can cross-talk with your legacy investment. And number three is you truly want to innovate. So if there's a new service which is available for, let's say, on one of the clouds, you don't want somebody telling you, no, I don't want you to use that, right? So these are the three tenets. And so on one hand, we see that people want to build very rapidly domain-based smart applications, right? And they don't want any data silos. They want to make sure information travels between these silos. You want to coexist with your existing investments. And then you do want enterprise-grade features. You do want the stuff that we all take for granted: security, performance, scalability, manageability, failure handling, fault tolerance, and so forth. So you want all of this stuff, right? So this is the picture that you end up inheriting, right? So I'm going to talk about, so what is a cloud data mesh? So increasingly what we find ourselves is in this view, where you actually have, maybe just, I'll give you an example of maybe one data mesh with multiple different decentralized teams that are using microservices to build their own applications. And these teams are decentralized, their architecture is decentralized, and their end consumers want to control the format of the data that they want to actually publish to their end consumers, okay? And more frequently what we are seeing is a permeation of this across different clouds, and that's what I mean by a cloud data mesh, okay? So that's kind of the core foundational aspect of what a cloud data mesh is. And one core thing is that data for correctness and for consistency needs to move across these different systems. That is by far one of the biggest challenges. So last year I talked about it that there was a lot of hoopla around data mesh. And one of the core things was that it's an ecosystem of products that kind of need to play nicely with each other. And I talked about the fact that data consumers are becoming very greedy and very savvy, where they want to actually be able to get the data in their own format and share it in their own format, okay? So the challenges there were data freshness, data organization, data visualization, privacy, automation. So this was from last year. For those of you there's a deck available exactly on that topic from last year. But one of the core points here that I wanted to make was the core idea of batch makes the mesh very unstable. And particularly as we are moving towards more, on one hand, we want to be able to interact with something like a Genai enriched application. So already on LLMs that are trained from as of 2021, we sort of reduce our workloads to a subset of applications, and we don't want that. What we really want to do is ensure that when I'm actually interacting with an application, it actually adds on to my experience, doesn't take away from the experience. So batch actually makes the mesh very unstable because of inherent correctness and consistency problems between them. And also it's a lot more cumbersome to manage, not to mention the cost part of it, because if you repeatedly take data over and over again in an ETL style, then that's super expensive. So, effectively what this brings us to is the notion that a mesh needs to be connected with something that I call an automated continuous data pipeline that actually keeps running in the face of failures, okay? That's a key point. A lot of people claim to do a lot of things, but it is difficult to actually keep a pipeline operating continuously, particularly because newer types of failures that we are encountering in the cloud, because they're at the back end, these are all, again, it's an infrastructure layer, so there's a lot of errors that are getting surfaced there. And so you need to be able to make sure that a pipeline, when it gets disrupted, doesn't disrupt the parallel flows, and number two, is able to resuscitate and revive itself. So recovery is a cornerstone of that pipeline, okay? So let's briefly revisit streaming for those of you who may not be familiar. I'm going to go super fast on this. The way I look at this is, if you take a look at a database table, you have a lot of records there, and you express queries on it. If you look at a streaming system, there's a lot of queries that are standing, and the data kind of flows through it, okay? And the data flows through it in these events, and these events actually are very interesting things. They capture real-world business entities, and you could have a partial event or a complete event, and the event itself can have data and metadata, right? So streaming is all about making sure that these events, as they're flowing through, how do we bound them so that we can make sense of them, and how do we process them? So these are some examples of events. You guys are familiar with this. You guys get text. If you get a text, you have an event. Okay, that's an event. And so there's a lot of vertical applications like the stock market, IoT devices, workflow management, user-level authentication that generates these events. I do want to separate. This is my concept number 2. I do want to separate a database change event than a normal change event. okay? Because in a normal change event, typically you get a complete record. In a database change event, you may get a partial record. If I, for example, if I go in and I'm talking to Aurora MySQL, and I say, hey, update my email address, the update from the database might just have my key, which is the primary key, along with a before image and an after image of my email address. And then I can pass that along. Now that's a partial update. So you need to be able to handle that separately than if the entire event was available to you. And that's an interesting concept. So to address that, there's a whole area of change data capture. And change data capture is a very cornerstone technology of streaming. I do want to point out, like a lot of, I get this question a lot, like, hey, doesn't Kafka address all your streaming requirements? No. Kafka is actually a distributed messaging layer that helps you efficiently store streams at scale. But it doesn't allow you, for example, to go in and deal with these complicated database change events, okay? So you do need additional technologies to kind of deal with that. And that's sort of one of the areas that as you think about streaming and data meshes and eventually your AI applications, make sure that the way in which the data is being collected represents a pattern that's sequential. You want to go against the log and not against the actual application tables, which is like random I/O, and that's going to be super expensive, not to mention that you're going to scan the entire world, which is super expensive. So the 4 key pieces that you need here for this architecture, number 1, you need a way to continuously collect data from not just databases, but from other application sources, messaging sources, file sources, and so forth. Number 2, you need a high-speed messaging tier, which needs to support both in-memory as well as persistence. And the persistence part of it is really where Kafka comes in. So Kafka is a piece of this infrastructure. It is not the entire infrastructure. It is not the entire architecture. Number 3 is stream processing. If you want to be able to do continuous analytics, if I want to count things super fast, you need to have a query processing engine. And that's the other piece here, because if you want to do push-based analytics, if you want to invoke your AI models in real time, you're going to need that tier. And finally, you need to be able to deliver this data somewhere in an efficient way, in a scalable way, so that you can, let's say if I'm writing this to Snowflake or BigQuery or to Azure Microsoft Fabric, you know, on my source, let's say which is a Postgres, I'm collecting the data through a stream. So I cannot apply this single-threaded. I want to be able to make sure that I can multi-thread this and use as many connections that the end system can support from the processing perspective. So that there's a lot of you need to be careful that you can scale the workload on the streaming part of it, okay? So there are 3 streaming patterns here that I really quickly, I know this is an eye chart, it's going to be tough for you to quickly digest it. This was from my talk last year. 1 is real-time data integration. That's pattern 1, right? Where all you're trying to do is do modernization. So you have like hundreds of databases on-prem, and now you want to move them, or you want to replicate subsets of them to the cloud. And so a classic real-time data integration pattern is the first pattern. The second pattern is what actually allows you to integrate with AI applications, as well as do streaming analytics using data windows and things like that, right? So that's the second piece of it. And the third part is sort of the reverse ETL. And this is actually becoming very relevant to Genai, because if I have an application, let's say Salesforce or HubSpot or Square or Stripe or whatever the application might be, you want to be able to integrate and enrich the prompts for the end user to kind of take advantage of what is the customer 360 here. That's pattern number 3, because now most often that customer 360 is going to come from an analytics system, not from the operational system, right? So this is how these patterns are kind of interrelated. And you know, just a quick thing. So I work for STRIIM, so I'll just do one plugin, and then I'm going to move on from this thing. So STRIIM is a platform that actually allows you to address those 4 fundamental capabilities, where there's CDC collection as well as collection pieces from messaging systems and file systems and over TCP and other protocols. We actually have a query processing engine that allows you to, for example, just subset the data or mask the data or hide private data or split the data. We have a router component. And you can actually pre-create context, preload context to do joins against that. And also there's very sophisticated capability to do pattern matching and anomaly detection, as well as machine learning functions that are available for you to actually program that inline. And this is something, by the way, not jumping on the bandwagon. I'm going to share a paper later on from 2018 where we introduced machine learning into over data streams, and we were amongst the first ones to do that. And so the way you work with STRIIM is, you have a no-code, low-code, and an API-based interface. Typically, you live in the Flow Designer. That's where you actually put together your various integration patterns. Okay? So this was the paper that I talked about in 2018. We presented that at the Very Large Database Business Intelligence session. And this is the part where we talked about machine learning models can be used to score against real-time data streams. So with that, I'm going to actually come in and talk about the actual application today that I have in mind. Okay. So far, just to kind of recap, the concepts we talked about were what's a data mesh? Okay. So that's sort of like a number of different disparate specialized engines or endpoints that are connected together, and the connection, the backbone for that, I've tried to convince you that streaming is the backbone for that as opposed to batch. Because of the inherent complications in batch. Then we talked about, hey, what are the key pieces if you wanted to support that infrastructure to address the challenges like the performance and the correctness and the consistency and the automation and the trust. So that actually is it brought me to a unified platform or unified service that should be able to address that, and why solely one of those pieces is insufficient to address this problem. Okay, so I used to be the CTO of a company called Golden Gate, which is now at Oracle. So, that technology is all about, data replication. It is not about stream processing. It is not about AI, right? It's database to database. So this actually moves up in the industry the workloads that we are actually trying to solve, which have to do with sort of, supporting real-time event meshes, event movement across the entire data mesh, okay? So that's what I've covered so far. So now with that, let me get into the data-driven Genai application. So this is really what all of us are talking about. There's a lot of customers that actually want to talk to us about it. How do I integrate AI into these things? So today what I want to do is highlight a Genai application that accepts a user query for doing a product search. It's for an e-commerce company that we're going to see. And the idea is that we want to be able to take all the product descriptions. So product descriptions could be like a page. It could have like typically the way it could be a page. The page could have like 500 words. The words could have like 3,000 tokens, and these tokens need to actually ultimately be fed to an LLM for tokenization and so forth. So it's an area where we want to embed a lot of these product descriptions, and we are calling those vector embeddings. And recently, for those of you who have been following, Postgres announced an extension called PG Vector, which is a new data type to support these embeddings. So we'll see the use of an actual vector embedding within this application. And then we're going to actually do a similarity search using an LLM based on the actual embedding that I'm going to show you in real time. And finally, we'll see that from an endpoint, if I'm a user searching for a product, I get a response. And then a supplier goes ahead and updates something, and in real time, the description is going to create a new embedding, and it's going to modify the behavior of the language model to give a more appropriate answer, a better response, which is really what we're trying to do. We're trying to enrich the experience as opposed to take away from the experience. Okay, so I'm going to run this demo, and hopefully I'll have some time for Q&A at the end also. So let's go ahead and play this. And I'm going to try and see if I can pause this too along the way. So the idea is that this is an e-commerce company selling toys. We want to add generative AI experiences for our customers. In this case, the data mesh is Oracle is the inventory management system where all the products are. Google Cloud SQL, either Postgres or AlloyDB. In this case, Postgres is the storefront, and that's where you're a user that's searching for query for the actual products. So there's the application that says, oh, the user types in a query, oh, what product should I show? That's the storefront. So that's the Cloud SQL storefront. That's an endpoint in the mesh. Oracle is another endpoint in the mesh. STRIIM is sort of the unified platform that's connecting the mesh here, and that's going to be invoking the embedding along the way as we take the data. Okay, and then we're also leveraging Postgres' vector extension, which is available to do the similarity search. Okay, so I think I can play this now. Okay, so this is sort of the picture, and I don't know how exactly to pause this, so I'm going to use my So here's the Oracle database. So you can see there's a product ID, product name, and the description. There's no embedding right now, okay? So right now there's about 850 products here. And now we're going to go to the poster side, make sure there's no products there. This is the initialization phase. And you can see the count is 0. Okay? And so now what we want to do is do a one-time load of all of the inventory into Postgres. So this is the flow designer in STRIIM, where there's a reader that can actually take, like a one-time snapshot of all the products. And here's the actual invocation of the embedding. So in this case, I'm using Gecko, which is from Google. That's going to leverage the Palm 1 API to do the embedding. And we're going to deliver the embeddings into another into the Postgres system. So from Oracle, no embeddings, and Postgres, there's going to be embeddings. So let's go ahead and run this real time. We start the actual pipeline. And you can see the connection is successful. First event is received. And 850 messages are already processed. Now if I go ahead and do a count from my products table, not only can you see my schema that was earlier, till the description, you can see that the vector embeddings are encoded as well, right? So this is a one-time initialization. So far, we have just sort of shown that from one point in the mesh, I can in real time move the data to another point in the mesh. And now, I got to pause this thing here. OK, I'll just talk through. This is the actual application itself, which is the Genai application. It's written in Python. By the way, this code is available. So for those of you who are interested, I can actually share this code with you. So this is the one where the actual similarity search, et cetera, is done. OK? So let's actually go ahead and hopefully it's playing here. Yeah. So you can see that it's not important. I mean, I just wanted to, because it's hard to digest the code in this format. But if you come to the booth, I can walk this some of the code with you. And ultimately, then now I want to show you the interface here. So the end user comes in and types and says, hey, I want to buy a toy that is safe for my child. Okay, that's the idea. So here's the actual query. Do you have a beach toy set that teaches numbers and letters to kids and is also child safe? And you can see there's an 18-piece product, which was $23. So now we're going to go in on the Oracle side and go ahead and update a product description where the supplier is going to say this toy is actually, in fact, is safer. And now we're going to see the real-time embedding of that. So let me go ahead and run that pipeline. This is the one that's using the change data capture from the Oracle redo log and embedding it in real time using the invocation to the Gecko embedding library. And it's going to move into on the Postgres side. So you can see that the description says keep your little one safe, right? That's kind of like the safety description there. Here's the update statement where we have fired on the Oracle side, and it's going to pick that up. And now this is captured in real time, and the corresponding embedding is propagated to the target Postgres database. Okay, and then we're going to log into the Postgres database and verify that that is in fact in there. So there you go. Start your kids' creativity now, and there's the embedding. This is the new embedding, and so now the user is going to come back, and we're going to run sort of the same query again to say, do you have a beach toy that teaches numbers and letters to kids? And in this case, my product is different, 44 pieces, $31, and it actually says made with non-toxic, high-quality materials. So the description that was added in my inventory system through a vector embedding was actually propagated on the Postgres side. And on the Postgres side, we actually did the search. And what I'm trying to showcase here is the combination of the real-time embedding in the STRIIM pipeline, as well as on the Postgres side, the fact that it's actually going through and making a query with an enriched prompt with that embedding against the LLM to modify the behavior of the application. Okay, so that's kind of the overall demo here. And then, that was sort of like my last demo here. Now, please try STRIIM for free. You can come in and also join our academy, and we have free certifications on generative AI and streaming. Our booth is right here, and we are more than happy to answer any questions and to show you some of the capabilities of the platform. And thank you for your time today, and it's wonderful to be here, and look forward to engaging with you guys. Thank you so much. Do we have time for any questions?
We have 5 minutes.
5 minutes? OK, we do have time for questions. Yeah. OK, there's a question right here.
Coming. Hello. Here you go.
Hi. What model do you use to generate embeddings, and how do you measure the quality of your embeddings? How do you measure the performance?
The question is, what do you use to generate the embedding, what model, as well as how do you measure the quality of it? So in this specific case, you saw in the embedding processing, we had Gecko, which is available through Google's Vertex AI model. So that's what we're using here. And in terms of the fidelity of it, I mean, that's a great question. Ultimately, I think from the Oracle database itself, which is the inventory management system, that's where the quality checks are done. So you won't be able to actually update a product in real time without going through the quality checks there. Now, in terms of the quality of the model itself, I mean, in this case, I think the model is trained only on the specific product set, so the fidelity of the data is actually very high, as opposed to sort of a general, OpenAI type of a model where I'm trained on, Wikipedia and all the other documents on the web. So in this case, the quality is going to be pretty high. Other questions? Question right here.
How do you ensure observability?
Yeah, the question is how do you ensure observability? So within the STRIIM platform, there is actually a monitor interface. And if you saw in my flow designer at the top, it said, hey, number of messages that are moving, the last time that I received an event. In fact, you saw that the first event was received. And so if you drill down into the monitor page, there's details about the various artifacts in the pipeline, including the source system, the actual embedding layer, as well as the target system. And you can see all kinds of details and metrics. In fact, I think we have close to 600 or so metrics that are available for you to actually monitor the pipeline. And in fact, you can run multiple pipelines and monitor all of that through a central monitoring page as well. Sure.
Hi, how do you manage, like you were saying, batch and real-time transactions in one? Like, because a lot of businesses have batch processes and real-time processes. So how do you manage?
Yeah, great question. So the question is, how do you manage both batch and real-time processing? Because a lot of businesses have both. Yeah. So ultimately, I think in the context of what we are talking about, imagine that you have a batch transaction. So that gets submitted against some set of database tables. That actually generates the log, which is the actual write-ahead log. So in this case, we're capturing the changes from the write-ahead log. So it's going to go ahead and capture the changes both for the batch transactions as well as the single transactions. I think I'll just extend the question. What do you do if the batch has 25 million events, and let's say it doesn't commit till the very end? What happens to latency? And that's a good question, and there's no getting around it really, because somebody has paid the actual forward-going penalty to submit that workload on the source database, and until you see the commit, that workload is not available to you. So I think as we are pushing that onto let's say the target database in this case, either you apply them in one transaction, in which case it's going to pretty much mirror, let's say if it took you 20 minutes to run that batch here, it's going to exhibit a latency of 20 minutes for that specific transaction. So in the real world, the way customers actually deal with that is they can actually go through and break that up through the pipeline, and you can actually say, hey, based on certain filtering criteria, I can use multiple connections to the target because I want to break this batch up. And now you can actually apply those in parallel. Now this is an application level, assuming it's not violating your application level constraints. So as long as you can apply them in parallel, then you can bring down the latency down to a bare minimum, which is typically how people address that. Other questions, comments? Okay, in that case, thank you so much for attending today, guys. I appreciate your time.
Thank you.
And check us out, we're right there.